My God. Practice. Practice makes a man bitch. Threesome.
Okay, let's solve LeetCode 15 3-sum, the sequel to the popular question 2-sum. So before you solve this question, the first thing you should do is make sure that you've solved 2-sum, which is the most popular question on LeetCode, so you've probably solved it or at least seen it before. I also recommend solving 2-sum 2, which is basically 2-sum except the input array is sorted. A lot of people skip this question. I think that's what makes 3-sum a little harder because they don't solve this one first. If you solve 2-sum and 2-sum 2, this question 3-sum is pretty straightforward in my opinion. But okay, let's get into the question.
Just a second, guys. Amazing, yaar. Amazing. If you cannot build logic, you cannot solve lead code. I didn't knew that.
So we're given an input array of n integers as per usual. This array though can have duplicates as we can see in the example, right? 2 negative 1s in this case. Now what we want to do is find 3 numbers of this array, so A, B, and C, and we want them to sum to 0. So in the example, there were 2 elements, or 2 triplets that summed to the total 0. Now, one problem is that we cannot have duplicates in our solution. So we're going to have to keep that in the back of our minds. So let's just start the most brute force way. We see that we need 3 numbers, so why not just have a triple loop, right? Just get every single combination of 3 numbers. That's probably the first thing you're going to try, right? So let's say our first number is -3. This is our A. So we're going to try each of these numbers for B, right? This could be a B, this could be a B, this could be a B, this could be a B. This last one can't be a B because we need at least one number to come after it so that it's a C. Now, if we did that with our triple loop, we would find that there is one such combination starting with -3 that will sum to 0 if we take 1 as our B and we take 2 as our C value, because then we'll have -3 plus 1 plus 2, that's obviously 0. So to our solution set, we can say, okay, there's a -3, a 1, and a 2. So now when we move, we can consider this as our first element, right? But eventually we'll see that we go through the entire thing and we don't find anything that can be added to 3 that'll give us a sum of 0. We'll do the same for this one and there isn't anything. Now we get to a -3 again though, because remember there are duplicates in this array. So now we're saying again that we're going to put -3 in this first spot. Now this is a recipe for finding duplicates. This is not good. And we'll see in this example, that's exactly what's going to happen. We'll take this as our B, we'll take this as our C. Again, we find -3 plus 1 plus 2 sums to 0. So then we're going to add that again to our result set, right? But that's not what we want. We want to eliminate the duplicates. So the problem was we took -3 as our A value, right? And then we searched the rest of the array for 2 numbers, 1 and 2, that add to 0. But then we went back here, right? And we found the -3 again, and we did the exact same thing. The problem is we don't want to have the same number in this position, in the A position, twice, because then if there are the numbers that come after it, we could potentially find duplicates. The solution to this problem is to sort the input array. Let me show you what I mean. So here you can see that the array is now sorted. Let's cross out our top array, which was unsorted. So now we are going to sort the input array. So now when we're looking for all combinations, if we find -3 first, then that's good. Okay, we'll say -3, then we find these 2 numbers, 1 plus 2, and then we find our solution. Great. Now if we get to -3 again, we'll say, hey, wait a minute. This number was already in this position, right? And we know that because its neighbor, its left neighbor, is the same value. We don't want to put it twice here because if we do, we'll get the same duplicate. So we're going to tell ourselves that we already computed all combinations that start with a -3. So we don't need to do that anymore. We already visited this one. We're going to skip this one and then we're going to go here. So that means in this case, we're not going to find any more results in the remaining portion of the array because they're all positive. They're never going to sum to 0. So then in our result, we're only going to have the one triplet, -3, 1, and 2. We eliminated duplicates by not reusing the same element twice. I think it helps to understand a little bit about the statistics of like combinations and permutations to like understand exactly why this eliminates duplicates. But I hope this explanation at least helped a little bit. So now that we know to sort the input array and we know how to eliminate duplicates, once we find our first number, notice, right? So let's say we have a -3. So then the remaining part of the problem, there's only 2 elements, right? So it basically reduces to 2-sum. And you probably know how to solve 2-sum, right? Obviously, we can put the numbers, let's say that this is our first A, right? So then for the remaining portion, we're basically going to do 2-sum. And you can do that with a hash map or a hash set. But if you've solved the problem 2-sum 2, you know that we don't need to use a hash map. We can use a left and right pointer. So this is our left and this is our right. And if we find numbers such that left and right added to our -3 sum to 0, then we're going to add them to the solution set. If the sum though is too big, for example, if our sum was greater than 0, we want to decrease our sum. Now we can do that by taking our right pointer and shifting it. So our right pointer would be shifted here. Notice how that decreases the sum because the numbers are sorted. So if you've solved 2-sum 2 before, you know exactly why this works, and I encourage you to watch that video if you want a deeper explanation. Now, on the other hand, maybe our sum is too small, our sum is smaller than 0. In that case, we would shift our left pointer. Because the input array is sorted, if we shift our left pointer, we're increasing the sum. Now, there could be duplicates among these left and right values too. For example, if this 1 was a -3 instead, right? In that case, we don't want to reuse the same element twice, even among our left and right values. So we would not use the same, we would shift our pointer once more over here. We don't want to reuse the same value for left and right either, so we don't get any duplicates. Now, in terms of time complexity, remember we are sorting the array, which is big O of n log n. And then we are not doing the brute force with triple loops. That would be n cubed. We are using the fact that this input array is sorted to our advantage. We're using one loop to tell us the first value, and we're using the second loop to basically solve two sums. So we're going to have two nested loops, and that's going to give us O n squared. So that means obviously the time complexity reduces to just O of n squared. Now the space complexity will depend. So for the implementation I'm showing, it could be big O of 1 or it could be big O of n, because sorting actually does take extra memory in some libraries. So it depends on your implementation of sorting. It could be O of n. Okay, now let's get to the code. So we remember we have to return this result as a list of lists. And remember, the first thing you want to do is sort the input array. Next, we want to use each number in the input array as a possible first value. So I will iterate through the index and the value. And remember, we don't want to reuse the same value in the same position twice. So if I is greater than 0, meaning this isn't the first value in the input array, and this value a is equal to nums of I minus 1, that means it's the same value as before. That means we want to continue. We don't want to reuse the same value twice. So we're going to continue to the next iteration of the loop. Next, we're going to use our two-pointer solution for the remaining portion of the array to basically solve two-sum. So we'll have left and right pointers. Left will initially be I plus 1. Right will be the end of the list, length minus 1. Left and right can't be equal, so we're going to say left is less than right. Now we're going to actually compute the sums. So we'll say our 3-sum is a plus nums of left plus nums of right. So if the sum is too great, remember, if it's greater than 0, which is what we're looking for,
Alright, so did we got the thing? I'm having chai. That's the most necessary thing we need in life.
Then we need to decrease it, in which case we would say our right pointer needs to be decremented. On the other hand, if it's too small, we need to make the sum bigger. If only I could type today. If it's too small, we need to make it bigger, so shift our left pointer to the right. The last case is if this is equal to 0, so of course we have to add it to our result. So to our result, we're going to append all three numbers. So the numbers are a, nums of left, and nums of right. Now, of course, we got to update our pointers, but how do we update it? There's a lot of ways you can do it, but I'm going to show you the way that you can do it with writing the minimal amount of code. So let me just write a comment to show you a little bit. What if we had the two sum basically for these left and right, and we were at -2, -2, so -2, 0, 0, 2, and 2. What if our left pointer was here and our right pointer was here? In that case, we found a solution, let's say, right? Then we'd want to update our left pointer, right? So then our left pointer gets to -2 again. But that's the same one as before. So in that case, we want to update it one more time to get it over here, right? Now in that case, now our sum is going to be too big because we're going to be at 0 plus 2. So that's greater than 0. So then our loop is going to execute saying that this is too big, and we're going to shift the right pointer to the left. But notice how that right value is now the same as it previously was too, but that's okay because our sum is going to evaluate as too big, so our right pointer is going to be shifted again. Notice how each value is only going to have one corresponding value that it can sum equal to the target, which is 0. So we only have to update one pointer, and our two conditions up here will update the other pointer by itself. We don't even have to worry about it. So in this case, we're only going to shift our left pointer. Because we don't want to have the same sum, we're going to have to use a loop. So in this case, if nums of left is equal to nums of left minus 1, that means it's the same value, so we have to keep shifting our pointer. But remember, we don't want our left pointer to ever pass the right pointer, so we're going to add that to the condition. So this is all we needed to do. Now I believe, unless I've made another stupid bug, we should be able to just return our result and pass the problem with the most optimized solution. Okay, I'm praying that this works on the first try. Let's see. We passed the test case, the first test case. They really want you to buy NeetCode Premium. This is taking... Okay, so it did pass. Usually I have some stupid bugs where I mess up a condition, but okay, so we passed it. Pass the test my solution. Able to just do. Now I believe, unless I've made another stupid bug, we should be able to just return our result and pass the problem. So in this case, we're only going to shift our left pointer. Because we don't want to have the same sum, we're going to have to use a loop. So in this case, if nums of left is equal to nums of left minus 1, that means it's the same value, so we have to keep shifting our pointer. But remember, we don't want our left pointer to ever pass the right pointer, so we're going to add that to the condition. So this is all we needed to do. Now I believe, unless I've made another stupid bug, we should be able to just return our result and pass the problem with the most optimized solution. Okay, I'm praying that this works on the first.
Alright, and I got it. What the thing he's trying to do. Okay, but इसमें क्या है कि हमें तब तक ऐसी अप्रोचेस को बार बार देखना पड़ेगा जब तक हमें रटना चाहिए चीज़ें, ठीक है? तो इसके लिए बेटर ये होगा कि एक अपन एक वो लेके चलते हैं, सम काइंड ऑफ नोट शीट और समथिंग लाइक दैट, जिससे क्या होगा कि हमें ट्रैक रखने में ईज होगा, ठीक है? तो ऐसा कुछ नोट वगैरह बनाते हैं, पहले क्वेश्चन सॉल्व करते हैं, उसके बाद एक नोट बनाते हैं, एंड then we'll see. Okay, so what he did, will be having int left, int right, nums dot length -1. Then we will be having an array, एक array list, ठीक है. list list of integer arr equals to new array list, because array list is uh, extending the list class. Right now, for int of I equals to 0, I is smaller than nums dot length I plus plus, और इसको हम यहाँ पे यूज लेते हैं because I plus 1, ठीक है. Now while r is smaller than, sorry, L is smaller than R, ठीक है, if int sum equals to nums of I plus nums of L plus nums of R, right? So if sum is greater than 0, then do what? Do R minus minus, else if sum is smaller than 0, then L plus plus, okay? Else what, do what? Else we got the thing that sum is equals to 0 and we need to append those uh, indexes, but before than that we also need to sort the array that we forgot. Okay, so arrays dot sort we use to sort the array. Okay, uh, the second thing which we want was but one thing here is that continuing thing. We got it for the first time. So arr dot add Oh, memory limit exceeded.
First try, let's see. We passed the test case. The first, just return our result and pass the problem with the most optimized solution. Return net points itself. We don't even have to worry about. Same sum is equal to nums of left minus 1. That means it's the same value, so we have to keep shifting our pointer. But remember, we don't want our left pointer to ever pass the right pointer, so we're going to add that to the condition. So this
Hmm. All right. What is more efficient? Need to check for the solution as well. बिग बिग ऑफ वन तो है ही नहीं. I need an Excel also. So we will keep note. Question number 15. Called threesome, and here we will add the approach. use solution with aim for big of and square time complexity. Use to two pointers left and right for iterating. पहले करता है use for loop for iterating over the array and use two pointers left and right to iterate to find some combinations to eliminate duplicates. You can sort the array first. Right? Aim for big of n square time complexity. Use for loop for iterating over the array and use two pointers left and right to find some combinations. To eliminate duplicates, you can sort the array first. Alrighty. This is for the two sum. Okay, questions, approach. यार मैं इनको वो करना चाह रहा था बट कोई नहीं. So we have done this one. Let me see my progress. So I've been doing This one is done as well. Now container with most water. This is the question which has been asked in EPAM systems. I mean, like they usually ask this. So it can be any of them, container with most water or trapping rainwater. Just a second. All right. So our next question is you are given an integer array of n of height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I0 and find the height of I. Find two lines that together with the axis on the x-axis form a container such that the container contains the most water. Okay, return the maximum amount of water a container can store. Notice that you may not slant the container. So we have a height of 8, then we have 1, 2, 3, 4, 5, 6, 7. So 7 vertical lines, uh, and then we have a last line of height 7 as well. So how did this container got an area of 49, which is the maximum area uh, which can contain the water? Okay, otherwise it will overspill if the height will increase from 7 to 8, like from height of the water only. So in that case, it will become overspilling, right? So यहाँ पे हमें इन दोनों की हाइट निकालनी है, मतलब मैक्सिमम पॉसिबल हाइट जो हो सकती है, right? So what we can use two pointers because these questions are generally falls in two pointers, and we uh, can use the maximum area, all right, and then we can return it. Let's do this one. So int l int r equals to I dot length -1 while L is smaller than R. We can have int container or max, or we can use container area equals to, let's go with the 0, right? Okay, So we will go like this. Let's go here and do some overview of this stuff. Alright. Alright. So what we're gonna do is we're gonna use an L and R. Okay. And how to increase. Nah. Yeah. We will be having L like this. Okay. So in this case, what will whatever will be the uh, uh, water area we are getting in the container, we will take it as the most acquired water. Okay, so that will be the first case we will keep in our mind. All right, and further, as we will move our pointers, we will keep comparing the previous water filled in that container with the right away uh, uh, what we have while iterating those pointers. Okay, so let's say in this scenario, how much water we will be having in the container of height 1, and here is height 7. Okay, within this we have area of 1 2 3 4 5 6 7 8, Okay, so we have uh, we have a length of 8 and a height of 1, so we will be having how much water contained in this area? We will be having 8. Okay, only 8. Then we will be having this height, so we have shifted the length, I mean not length, the left pointer to the second most uh, a vertical element, which has the height of 8. Okay, we will keep this in here only. So what logic uh, we will follow is, we need to have a logic to shift these two pointers as well. Like if we want to shift left one first or right one first, so in that case we can do it by comparing the height uh, from both the side as well. But we will see that uh, in our uh, in our solution while coding. Okay, so let's do that first. So we have this container area. Okay, so how do we uh, get the height of a container, which is length into height? Okay, so int area equals to nums of, not nums, uh, height of this, it will be height. So we need to check which uh, pointer is which pointer has the max height, that we need to see also, and then we need to uh, get the area. So we will check the max height, ght int max height equals to uh, math dot max height height of L, oh sorry, height of L and height of R. This is the height we got, and we can use a single variable only. So math dot max height we already got, and how we will got the uh, area, I mean the length of the container, we will be getting that uh, by length minus I mean L minus R. So it can be in negative as well, so we need to uh, do the absolute stuff over that thing. Let me show you how we can do that. So not this, into math dot absolute, I guess Java math dot absolute, math dot absolute. Okay, so in this we get L minus R, and here we get, and that's how we get the area of the maximum area we got of this. Okay, and instead of this we can also use this one, and of this Why it didn't work out? Okay, so which one has more area? We will get it by this math.max. Okay, so we got the container area, right? And we can then return this container area in the end. Then we need to have a logic to uh, we need to have a proper logic to iterate over this. So we don't we are not even uh, uh, sorting this array as well, because that will increase the time complexity of the solution, right? So how we can first I is here, let's go here. Okay, and let's use this. All right. Uh, all right. So the area which we will get will the maximum possible height. So in this case, it will be 8. Okay, when L is here and R is here, at that time area will be 8. Then we will check by moving this pointer to here. Okay, 8 and 7. At that point it will be 49, because the maximum length will be 7 and the height will be 7 as well. So 7 into 7 will be 49, and this area will get increased to 49 at this in this case. Okay, all right. So when can we decrease this one? I'm trying to figure out that part. 49. uh, we can do it like this. uh, if if the newly discovered area is not greater than, at that time we can do it. So what I'm thinking is, but that won't affect this one. Let's just increase one pointer first for the sake of uh, For the sake of testing, let's increase only one pointer. Let's see. All right, dot max 56 and it got 49. Here is the right answer, but it got 56, and why is that the case? Math.max, height of L or height of R? No, at that point we need to have the minimum height. So see, here is the height of 8 and here is height of 7, and in the starting of the question what I've told you that if either one if either height is smaller than the other one, then the at that time water will overspill, so that's why we need to use the min height. Okay, let's test now. Right, so now we got the answer, but still, because we are not using the right pointer, still there will be a case where it will fail for sure. Let's try to submit this. Yeah, so at this point it got failed, right? Because the output is 3 but expected was 7. And why was that so? Right was here, left was here, left to this was uh, 1 2 3, still got 3, but what we would have got is 7 because 8 and 7 is this. Yeah, I got the uh, I got the case where we will see the height of the towers. So if one of the height is smaller than the other one, in that case we will increase our pointers respectively. So let's say we have left pointer lesser than the right one, then we will increase the left pointer. Okay, so if height height of L is smaller than height of R, in this case we will increase left pointer, else we will decrease right pointer. Let's see what happens. Yo, you got it, bro. This should be included in like easy problem because that was the easiest one I could remember. Right now, uh, this comes as harder one, trapping rainwater. That's good. All right. है सुना ये सारी धरती तो जलाता है मेरी ले अर्जी घर बुलाता है all right, what this question says, let's see. Yes, so given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So, unlike container with most water, we have this one. Uh, and trapping rainwater is kind of like that one, but in this case we need to add the value of these boxes which can contain water. Okay, so each box has a height of 1, so let's say 2 box will be having height of 2. Okay, that's how 0.021010, right. So we got the height of we got the capacity of water contained within these boxes of 6, which is 1 2 3 4 5 6, right. And if one of its side has no boundaries, then water will spill in that way. Okay, the above elevation map black section is represented by array. In this case 6 units of water rainwater blue section are being trapped. Height of this will contain this much water. That's nice, bro. That's nice. All right. Then we have best time to we will be having sliding window. Then we will be having stack, binary search. This is my favorite topic. Like I don't know most of like all the question of it, but I like to uh, study binary search algorithm. Linked list, then trees, then heap and priority queue, then backtracking. Here we will get the recursion stuff, then tries, then graphs, then advanced graphs, then 1D dynamic programming, then 2D dynamic programming, then greedy algorithms, then intervals. I don't know what interval means, but we'll see. Math and geometry, bit manipulation also is very important. Okay, and so also we are about to complete 2 pointers, then we will move to stack. Not stack, actually sliding window. Stack will be there in the later section. Okay. मेरी बात सुन ले आज मुझे घर बुलाता है Alright guys, then we will do this question later on.